So this is my x-axis and this is my y-axis. Now suppose a mass m1 is here and mass m2 is here at a distance L. So coordinates for L will be for m2 will be L comma 0. Now I want to find out the center of mass for these two masses. So as we all know that m1 plus m2 into xcm will be equal to m1, what is x coordinate for m1, it is 0, plus for m2 the x coordinate is L. So xcm will be m2L over m1 plus m2. So somewhere here the center of mass is, and the distance for this from m1 will be m2L over m1 plus m2. Now the distance from this, what would be the distance from m2? That would be L minus m2L over m1 plus m2. That will be m1 L over m1 plus m2. So this would be m1 L over m1 plus m2. So this is the center of mass. Now I want to find out the center of mass of a ring, semicircular ring, like this. The ring mass is m. This is semicircular ring. So what I will be doing that this is a small section I will be taking. This is d theta and it's theta. So what would be this part? This arc will be r. The radius of this is r. This is the center. This is the origin. Okay, the radius is r. So r d theta. Now it's a semicircular ring of mass m. So what would be the mass for this r d theta section? So like for whole length, the length of this ring for means if it's a full ring, then it would be 2 pi r, and here it's a semicircular ring, so it would be pi r. So m over pi r multiplied by r d theta. So this is the mass for this small section. What would be the coordinates for this? So like here you can see the coordinates is r cos theta. X coordinate is r cos theta, comma y coordinate is r sin theta. So axiom, as we know the axiom, that will be I'll be checking both the axiom and ycm. So total mass, that is here you can see, must have seen like this. I will be doing here total mass, that is m1 plus m2. That means for whole of this ring the mass is m. So m into xcm is equal to, now this is the small section. I want to use it for the same for the whole ring. So I have to put integration 0 to pi. Theta will be 0 to pi, and now the mass m over pi r into r d theta. This is the mass into x coordinate. What is the x coordinate? This, because we have m1 x1 and so on, so r cos theta is the x coordinate. Similarly, for m ycm will be integration 0 to pi m over pi r into r d theta. This is the mass, and y coordinate is r sin theta, r sin theta. So what would be my xcm? Xcm will be mass. So r over pi integration 0 to pi cos theta d theta. Ycm will be r over pi integration 0 to pi sin theta d theta. R over pi sin theta 0 to pi. This will be r over pi minus cos theta 0 to pi, and from here xcm will be r over pi sin pi minus sin 0, and we know the sine graph, it's 0 and this is pi, so 0 0 it would be 0 xcm. Now ycm will be r over pi, this would be minus cos pi, and minus cos 0. As we know, in cos 0 is 1, and that is minus 1, pi is minus 1, r over pi, this would be 1 minus 1 plus cos 0 1, 2r over pi. So somewhere here at a distance of 2r over pi, this is the center of mass for this semicircular ring. Now if it's a semicircular plate like this, x-axis, y-axis, this is semicircular plate. I want to find the center of mass. So what I will be doing, I will be taking a small section of it, a ring, a small ring you can say I will be taking. And the distance for this is total distance is r, it is small r and dr. Dr is this distance, dr. So it's 2 pi r. It's not 2 pi r. If for half of the ring it will be pi r length, and area will be pi small r into dr. This is the area for this ring. for whole of mass for whole of this disk, each semicircular disk is m. So I'm going to divide it like if pi r square over 2, like for whole of this disk the area will be pi r square, but it's a semicircular disk, so it will be pi r square by 2. So I am dividing and the mass for this small ring will be this area, pi r d r. Now as we have seen in this in my previous as we have seen here that the center of mass for this ring is in the y-axis at a distance of 2r over pi. So I am considering it here somewhere 2 into small r over pi is the center of mass, where the mass for this whole of ring will be here. It's the center of mass for this small ring. And now we are going to put like for m into y cm, that will be equal to integration 0 to r. Now what is the mass? This is the mass, m over pi. I am putting the same thing here what I did here. So m over pi r square over 2 pi r dr. This is the mass into the distance is 2r over pi. 2r over pi. Now I am going to calculate it. Pi m. So YCM will be 4 pi r square integration 0 to r square dr, that will be 4 over pi r square r cube over 3, 0 to r, that will be 4 over pi r square into r cube over 3, that is 4r over 3 pi. So somewhere in this y-axis only, this is the center of mass. This is the center of mass. So somewhere here or there, the center of mass of this semicircular ring will be 4r over 3 pi. Thank you.